Okay, hey Chloe. This is Friday. We're starting R4 notes. Yesterday we just finished quizzes, which I'll have you do that when you come back. But here is R4. And first things first, I'm going to dissect the title of this a little bit. What are rational expressions? What's a rational function? You guys know what a rational function is? What?
It's not irrational.
Right. Okay, what's a radical function? Yeah, one of these guys, a square root, right? So radicals, we have more operations on radicals. So we've got square roots and stuff coming. But what's a rational expression? Rational expression. Because we just got done talking about polynomials, right? And multiplying polynomials together, like foiling and doing that type of thing. But now we have rational functions. Rational functions, like the simplest rational function is 1 over x. It looks like a boomerangy thing, right? But most rationals will be like, I don't know, x plus 7 over x minus 3, something like that, right? Or they might be like x squared plus 4x plus 6 over, I'm making these all up, x squared minus 9. I have no idea, right? Something like that. Those are all rational functions. Rational functions, okay? And what's going to happen to those guys is like this guy, he looks like a boomerang, right? But he has these little dotted lines that he's not going to touch, and those are called what? Yeah. Yeah. 1 over x looks like that boomerangy guy, and he has those little dotted lines. What are those dotted lines called? What are these little dotted things called? Dotted lines that he doesn't touch. What are those called?
The x and y axis?
Nope. Well, they're on the x and y axis.
It gets smaller and smaller, but never 0.
Yeah. It approaches, but it never. What is that called? What is dotted lines called?
Greater than 0.
He approaches, but he never touches these little dotted lines. What are those things called? Starts with an A. What? It sounds like a naughty word, but it's not.
What's the word?
Asymptotes. Yeah, it sounds like a naughty word, but it's not. It's asymptotes. The P you can't even hardly tell, but asymptotes. So this is a horizontal asymptote, so I call it a ha. And this guy is a vertical asymptote, I call it a va. Okay, now I'm going to give you a little preview of what's going on here. But in these functions, like looking at the equations, I can tell from the equation where the va and ha are, okay, by doing different things, okay? The va always comes from where does the x poop out, right? Like this guy is like where x doesn't touch, okay? So according to like, let's say like this middle function right here, what's the x gonna poop out at? Where are we gonna have a problem with x? Got any ideas?
Above 3. It has to be more than 3.
Or less than 3. It just cannot be equal to 3. True? Because if it was 3, then I would end up with 0 on the bottom. And I cannot have 0 on the bottom. Can you have 7? Or can you have like 0 on the top? Like if this was a negative 7, is that okay? Can I have 0 on the top?
Yeah.
Yeah. I just can't divide by 0. So I want to make sure that that's not going to be a problem. So what's happening here is because this bottom, x can't be 3, that means I have a vertical asymptote at 3. So now my dotted line is over here, and he looks like this instead, right? This guy, 1 over x, the reason why he has a vertical asymptote at 0 is because x can't be 0 on the bottom. Does that make sense? Okay. Now this guy, x squared minus 9 is on the bottom. Okay, but x squared minus 9 is the difference of squares. He is x plus 3, x minus 3. So where will his va's be at? He will have 2 of them.
-3.
He'll have a va at -3 and a va at +3. So what he usually looks like, if he has a va here, whoop, and he has a va here, a lot of times he'll have like one of these things going on. They'll have like 2 little loop-de-doos and like a parabola kind of in the middle. Okay, that's what he will look like. We'll get into that later. But vas are usually determined by what the x cannot be in the bottom. It's like where the x poops out of the bottom, or like what x can't be. Okay, ha's, we'll get into that. Have we talked about n and m before? No, we haven't. Oh gosh, n and m? No. No, because you guys are coming from geometry. We don't talk about that in geometry. So, ava is what x can't be. It's where the restricted values are. So that's the first thing it asks down here. Determine the restricted values for the rational expression. These are all rational expressions. Okay, it's like something over something, right? Rational expressions. So we have to figure out where the x is going to poop out at, basically. Determine the restricted values. So what can I have x not be?
-2 and 3.
X can't be. Can x be 3, though?
Well,
Let's talk about -2, okay? Remington said x can't be -2. If I plug -2 in, I've got -2 minus 3 over -2 plus 2, right? That's -5 over 0. Can I have -5 over 0?
so
No.
it's just negative.
Okay? But let's talk about 3. If I plug 3 in, right? 3 minus 3 on the top and 3 plus 2 on the bottom. 3 minus 3 is 0 and 0 over 5. Can I do that?
Yeah.
0 over 5 is just 0. I can do that, right? The only thing I can't have is the bottom be 0. So x can't be -2. So determine the restricted values. The restricted value is -2. Or you would say x can't be -2. Does that make sense? We just don't want that bottom value to be 0. Because what's happening at -2?
It'll be easier.
There's a va there. He's not going to touch there, right? A va is a place where he's not going to touch. A vertical asymptote is where he's not going to touch. Okay? All right, B. What do we got going on here?
I think it's 7, but then it'd be 0 over 0.
What do you mean?
No, never mind. It'd be 7 over 0.
A va is where the bottom
X can't be 7.
is 0, right? Okay, so let's just say x squared minus 49. He can't be 0, right? X squared minus 49, we don't want it to be 0. So let's solve for x, right?
7.
Let's add the 49 over. So x squared can't be 49. And if we take the square root, does that feel weird doing that when that's not an equal to sign?
Yeah.
Yeah? X is not equal to, what's the square root of 49?
7.
And?
Negative.
-7. Positive 7, -7, right? Okay? He has 2 vas. Or, what is this guy?
Simpleton. Or difference of
He's a difference of squares, right? He was x plus 7 and x minus 7. And if you set those equal to 0, x can't be 7 and x can't be -7. Because what happens if x is 7 or -7? He will have a va because he will be dividing by 0, and you can't do that, right? It's undefined there, right? Does that make sense? What about 0? Can x be 0? Like if I plug a 0 in, this would be 0 over 0 squared minus 49. What's 0 squared minus 49, by the way?
negative 4.
-49. Can I have 0 over 49?
Yeah.
Sure, it's just 0, right? So I can still have 0 on the top. I just want to avoid at all costs the whole bottom being 0. Like here, we set this whole bottom, x plus 2 can't be 0. That can't be 0. That means if we subtract 2, x can't be -2, right? Like what we had here. I don't want x squared minus 49 to be equal to 0. So x squared plus 49 is not equal to 0. And x can't be 7 or -7. What about this guy? Now we have an x and a y.
0.
So 7 equal to 0.
X can't be what?
0.
This one's kind of hard to think about. X
0.
can't be something and y can't be something. If x is 0, then what happens?
It just gets rid of that.
5 times 0 squared times whatever y is, that whole bottom is going to be 0, and we can't have that, right? What can y not be?
0.
0 also, because no matter what x is, anything times 0 is going to make that whole bottom 0. So x can't be 0, y can't be 0. Does that make sense? That's a weird one to think about, okay? So we want to make sure that that 0 doesn't happen in the bottom, okay? There are 2 things, and we'll talk about this like a lot in trig class. There are 2 things, really kind of 2.5 things, but two things that lead to domain errors is what I call them. Okay, write this down off to the side. 2 things that I can't have. What's a domain, by the way? What is your domain? Like domain and range. What's domain? X's, right? So these are errors that happen with your X's, right? Like with your input values, with the X values, okay? Domain errors, things that I can't have. There's 2 main ones that you're always trying to avoid. Only 2, that's it. We'll talk about a third one kind of later, okay? But 2 main ones, right? The first thing is I never want to divide by 0. I never want to have 0 on the bottom. That's going to cause me a problem, okay? 2 main things. I never want to divide by 0. I never want to have 0 in that denominator. So we fix it by saying, x can't be 7 or -7. X can't be -2. X can't be 0 and y can't be 0. That's how we restrict the domain, right? Those are restricted values. And the next thing is, if I have a square root, I never want to have a negative inside of a square root, right? I never want to divide by 0, and I never want to have a negative inside of a square root. Okay, so let's say we have this x, the square root of x plus, let's go minus 2, right? X minus 2. Here we would say, okay, let's say x is 0, right? If I plug 0 in for x, am I going to get a problem? Because it's going to be the square root of negative 2. If I plug 1 in for x, am I going to have a problem? Yes, because I'm going to take the square root of negative 1. If I plug 2 in for x, am I going to have a problem? If I plug 2 in for x, it'll be the square root of 2 minus 2, which is the square root of 0. Can you take the square root of 0?
0.
The square root means something times itself will give you that number.
0 times 0.
Yeah, so you can take the square root of 0. So 2 works, right? What if I plug in 3? 3 minus 2.
That works.
That works. What about 4? 4 minus
That
2.
works.
That works. What about 5 minus 2? That works. So I would say if I have the square root of x minus 2, I can't have any of these numbers that are less than 2.
So just
X would have to be greater than or equal to 2. Does that make sense? Okay. So that's how I fix that domain error. Here I say, oh, x just can't be 7. X can't be negative 7. Here I have to say, x just can't be any number less than 2, right? Okay. Or x has to be greater than or equal to 2. Kind of confusing on a Friday. I get it. Okay. Now, the other one little baby step for domain errors is if you have story problems, which I'm not going to add to here. There's really just 2 main rules that you have to follow, but the other one is story problems. Story problems. Okay, so let's say I have a, you don't have to write this down, but let's say I have a rectangle, right? And I'm solving for x and I'm solving for y. Can x and y be anything that they want to be? No. What can x and y have to be?
Y has to be bigger than x.
Not necessarily. Let's say I,
In that
like whatever. In that situation, it looks like y is bigger than x, true. But what does x and y have to be no matter what?
Different. They have to not be equal.
Maybe possibly.
Not wrong.
Maybe possibly, right?
Positive.
They have to be positive numbers. They have to be greater than 0 or equal to 0. I don't know. They'd have to be greater than 0, right? So that's another way that we restrict the domain is in story problems. Usually it has to be bigger than 0, okay? But for the most part, when you're dealing with equations, you have to worry about those 2 things. Not dividing by 0 and not having a negative inside the square root. Blah. Okay, let's go down here. Equivalent algebraic fractions. All right, simplifying rational functions. They want us to simplify this. How in the heck do I simplify that? X squared minus 16 over x squared minus x minus 12.
Break them down.
Yeah, let's break them down and see if anything cancels. Can I cancel x squared like this guy and this guy? Can I do that?
Yeah.
No.
Why not?
They're trapped by.
They're trapped by the pluses and minuses, right? Right? If this was x squared times 16 and x squared times x minus 12, then I could cancel those guys, right? But the way that they are now, they are trapped by the pluses and minuses, so I can't do that, okay? All right, so I can't break this guy down, though. What is he?
Difference of squares.
He's a difference of squares. The square root of x squared is x.
Plus 8x minus 8.
Oh, square root of 16 is
Oh,
4. X plus 4, x minus 4. Yep. Plus 4 minus 4. Okay, now on the bottom, he is a
Simple trinomial.
simple trinomial. Okay, so we're multiplying to get 12, and when I add them, give me negative 1.
3 and negative 4. Oh wait, no.
No, you're fine. Yeah, I'll go positive 3, negative 4. Plus 3, x minus 4. Yeah?
I thought she said 30.
Yeah? Okay, now what?
I did not say that.
I realized that.
Cancel x minus 4.
Cancel the x minus 4, so final answer is
X plus 4 over.
x plus 4 over x plus 3. Can I cancel these x's?
No.
No. Done?
Uh,
Is he simplified?
X cannot equal negative 3.
Right.
Or
X cannot equal negative 3. They don't necessarily make me say that, but yeah, that's good, a good thing to exercise, right? That's a restricted value. X can't be negative 3. True. They didn't ask for that, but that's fine.
I thought they were.
That's okay. That's okay. That's A. Got it? B. How do I divide that thing by 4? How do I simplify that?
Divided by 4.
When you're dividing by a number, this is the way that this operates. Ready? This is the same thing as 8 over 4 plus 2 square roots of 7 over 4. Right? I can break those down into 2 pieces. Kind of like you can put them over top of one roof, right? Okay, so now I can reduce. What does this become? 2? And what's this become?
2 square root 7 over 4.
The 2 and the 4 can reduce.
So 1 square root 7 over 2.
1 squared is 7 over 2. Or, you don't need that 1, right? Do you see how that works? 2 and the 4 reduce, okay? So, yeah, you can break those up into 2 pieces like that and get that as your answer to reduce. Got it? That's simplifying. Questions about that? Did somebody spray something? I smell like a fall smell.
There's something.
Did they turn my candle on?
It's not all the way up.
Is it in the hallway? It's probably drifting in from the hallway. It smells good. I like it. Okay. Okay. One more thing. This is what this little piece is illustrating. Let's talk about this. Let's say that on the top, I have an x plus 2, and on the bottom, I have, we'll just make this easy, negative x minus 2. Let's just say I have that going on.
X can't be negative 2. Well, it can't be.
Yeah, let's talk about that first. What can x not be? This one's harder to think about.
Oh, if it's negative 2.
I don't want this thing to be equal to 0, right? So I would say negative x minus 2 can't be 0. Yeah? Okay, then let's solve for x. So I'm going to add the 2 over. You do just like normal algebra. Negative x can't be 2, and I'm going to divide by negative 1. So x can't be
2. Or
negative 2, right? Now, what happens if I plug negative 2 back in here? I have negative 2, which is 2 minus 2, which is,
0.
and I can't have 0 on the bottom, right? Okay, so that's why he can't be. But let's say I'm trying to simplify this thing. How do I simplify that thing? Can they cancel out?
If you take a negative 1 out.
Okay, so x plus 2 on the top, he's just going to chill. But if I take a negative 1 out of the bottom and factor him out like a GCF, what's left after I pull a negative 1 out?
X plus 2.
X plus 2. And then what?
Cancel.
That cancels. So what's the final answer?
1 over negative 1.
1 over negative 1, which is just negative 1. You see how that works? Okay, so sometimes when you're looking for things to cancel, you might have to get a little creative, because if they're similar to each other, but one's just like attached to a negative, you might have to just pull that negative out before you can cancel them. Got it? Yeah, not so bad. Okay, next. Dividing rational expressions, example 3. We're on the top of the next page.
We should just do homework.
Yeah, we should just.
What do we have left?
Instead-
Let's finish example 3, because adding and subtracting is the hard part. Adding and subtracting is where it gets really icky. Dividing and multiplying is not so bad. Here, they say divide. I have this rational expression divided by this rational expression. And that's kind of gross.
We just have to break everything down.
We're going to have to break everything down. But also, divide. Instead of divide, I'm going to keep flip. I'm going to multiply by the reciprocal, right? So this guy is x cubed minus 8. This guy is, we're going to fix him here in a second. Hold on. Times, I'm going to flip this guy. X squared minus x minus 6 and 3x squared plus 6x plus 12. So I flipped that guy. Anytime you see division, you're going to flip it and you're going to multiply. Okay, so I just flipped this back piece. This part is kept. This part is flipped. This part is flipped. Do you see how that works? Keep, flip, flip. All right, I do not like 4 minus x squared. Don't like it.
X squared.
If I
Negative x squared.
take a negative 1 out of there, if I take a negative 1 out of this, what will he look like?
Negative 4.
Negative 4 plus x squared, or x squared minus 4. Right? You see that flipped around? And I like x squared minus 4 because he is a difference of squares. All right, so I'm going to write this guy as negative 1 times x squared minus 4. Can I get away with doing that? Okay? All right, so that's just weird things. All right? I know you look at some of this and you're like, how would you know to do that? You just have to do a bunch of problems and then you'll get used to knowing that you have to do that, okay? So it's hard to identify that, yeah, that's a thing that you have to do, but that's whatever. Okay. All right, let's start breaking stuff down. What is this guy? X cubed minus 8. Is he have something that we can break down? What?
X minus 2.
He's a difference of cubes, okay? Difference of cubes is A, whoop, minus B. This is where your note card comes in handy. A squared plus AB plus B squared, okay? So if we do that, what's
X minus
the A part? X minus, what's the B part?
or 2.
2. X minus 2, okay? What's A squared going to be? X squared. What's B squared going to be? 4. What's AB going to be? 2x. Okay, so that's what I have. X minus 2. I've got, I should write this in black. X minus 2. He is x squared plus 2x plus 4. That's that guy broken down. That was the hardest one to break down. Now we're golden from here. Okay? All right, this bottom one. Don't forget about the negative 1, but then this guy, x squared minus 4, is
X plus minus 2.
x plus 2x minus 2. He's a difference of squares. Got it? All right, top of the next. X squared minus x minus 6. He is a simple trinomial. Okay? We want to multiply to get 6, add to get negative 1. X. 3 and 2 is the combination. X minus 3x plus 2. Will that work? Will that do it? Okay, what about the bottom one? He looks like a complex trinomial, but you can take 3 out. Right? 3x squared plus 2x plus 4, right? Then is this a simple trinomial? Can you multiply to get 4 and add to get 2? I don't think there's anything I can multiply to get 4 and add to get 2, but check it. Check it out. Zoom out. Look at the big picture.
It's the same as
Oh, look at that. He can cancel. Do you see that? Do you see our pieces now? Now we have them all broken down. Do you see this? X squared plus 2x plus 4 and x squared plus 2x plus 4. Okay? When you get into a problem and you start focusing onto like little pieces, take just a second and zoom out and look at the big picture and say like, oh, hey, look at that. It cancels, right? What else can we cancel really nicely? X minus 2 right here and x plus 2 right here. Okay, so now that we are like almost done, we just write what we have all left on the top. What do we have left on the top?
X minus 3.
X minus 3. And on the bottom we have
Oh, negative 3.
negative 1 times 3, which is negative 3. Can I cancel these negative 3s? No, because the top one is trapped. The bottom one's not trapped, right? The bottom one could, get rid of wherever. But since the top one is trapped, he is done. Okay? Now, what can x not be?
It could be anything.
It can be anything. X is not on the bottom. Ha! Right? Yeah. Did you know, just for a fun fact, this guy is the same thing as x over negative 3 minus 3 over negative 3. So this is like negative 1/3 x plus 1. Was that confusing?
Yes.
Yeah, like this guy right here is negative 1/3. This guy right here is plus 1. Okay, you don't have to write it like that. You can keep it like this. Okay, good. That's a lot. That was a lot of stuff. Trig. Ooh. Trig. Trig is my scariest math class. And you're getting a little preview of why. Right? Is Trig the scariest math class? Yeah, maybe. Maybe. Okay. All right, there you go. Okay. All right, I would start working on homework, and you can do up to add and subtract rational expressions, which is, I don't know.
Can I go get my book?
Sure. Otherwise, I have one up here if you want to steal.
Take that one then.
Sure. That's fine. I'll keep, hold on, Chloe. R73, thanks. All sorts of messy here. R73, you can do up through 34 is all.
Where is it?
So it's like page R73, we've got 10 and 12 and 14, am I doing this right? And 18 and 22. And
34.
is there a 28?
Yeah. Districts are in
28 and 34?
Districts are what?
So those numbers.
Districts
There you
is
go.
in McCool.
Okay,
Actually?
Yes.
beautiful. All right,
That
goodbye,
is, like,
Chloe.
The best.